So in these two example problems, I'm going to move it where you can see it better. We are asked to solve a couple of exponential equations. Both of these problems can be solved by expressing both sides of the equation as powers of the same base. So it's the one-to-one property of exponential functions that says if we can write a function as b to the u equals b to the v, then it's implied that u equals v, that those exponents have to be equal to each other. But the important thing is that we write the equation, same base on both sides, with a single exponential expression there. So taking example 1, first of all, so we consider, okay, what power could I use as the base? And there are multiple options. But what may be most likely to come to mind is base 2. I can express the 1/2 there as 2 to the negative 1, and I can express the 8 here as 2 to the 3rd. Now we've got other stuff going on with each of these. On the left side, we have this raised to the 3x minus 6 power. And on the right side, we have this raised to the x plus 1 power. These are equal to each other. Now, on each side, we should multiply the exponents. That's what our properties of exponents tells us to do. So on the left side here, we have negative 1 times this entire expression. The negative 1 should get distributed to both parts here, so that the left side is 2 to the negative 3x, and then positive 6 when you distribute a negative 1 there. On the right side, we distribute the 3 when we multiply 3 times, well, let me write it this way first, just to help maybe clarify. So we need to multiply 3 times x plus 1, so that's why we're distributing here. So this will become 2 to the 3x plus 3. Now we've got the function in this, or the equation in this form. They're both sides are written as a power of 2, so we can drop the drop the bases and set those exponents equal to one another. And from here, solving the equation is fairly straightforward. You would now collect the x terms all on one side, so I might add 3x to both sides. I like to have a positive coefficient on my variable when I can, although it doesn't really matter. Oops, and I got 6 here. I don't need to write plus 6 because that's the only term left. Subtract 3 from both sides. So 3 equals 6x, and divide both sides by 6. And so our answer here is 1/2 is equal to x for that first equation. All right, but that second part is just solving a linear equation. It's the first part, the expressing both sides as a power of the same base, is where you're going to have to put some thought in. So looking at the second example, again, I want to try to write both sides as a power of the same base. In this case, the base that might be most likely to occur to you is base 5. The cube root of 5 right there could be expressed as 5 to the 1/3 power. So that's the 1/3 power, but then I've got that whole thing raised to the negative x. And then on the right side there, so I've got 1/5 raised to the x plus 2, but I want to rewrite that 1/5 with base 5, so I could write that as 5 to the negative 1. That's the same as as 1/5. Now in each of these cases, I now need to multiply the exponents. So the left side is 5 to the 1/3 times negative x. So I'm going to write negative x over 3. The right side is 5 to the negative 1 times the whole quantity x plus 2. Make sure you distribute the negative on that to both terms here. We've got both sides expressed as a power of the same base, so I can drop the bases now and say, okay, so what I have in the exponent on the left, negative x over 3, is equal to the exponent on the right, which I'm going to go ahead and distribute the negative if that's all right with you guys. So negative x minus 2 when we distribute the negative. And now I want to solve that equation for x. So again, now we're looking at a linear equation. One thing you could do, so since the equation involves fractions, don't forget you have the option of multiplying. I would clear the denominator by multiplying each term by some quantity. In this case, if I multiply everything by -3, so multiply this by -3, multiply this by -3, multiply this by -3. Here, the 3's would cancel. Negative times a negative is a positive, so I end up with positive x equal to negative x times -3, so that's positive 3x. And then minus 2 times -3, that's positive 6. And now I could subtract 3x from both sides. So I have negative 2x equals 6. Divide both sides by -2. And I end up with x equals -3.